All right. I think we are live. Yep. Nice. All right. So today we're picking up where we left off last week, and we're doing this walkthrough for Axum, Tonic, and Tower by FP Complete. So I think this is Functional Programming Complete. Nice. So yeah, we're gonna go through this, part 3, and then part 4 of this today. So we'll see how long that takes. Next week's stream is going to be about adding Lua into our envim config. And I tried to do it some yesterday and I might have messed some things up. So if my envim starts freaking out, that's gonna be what that is. But we got our water, we got our espresso. Let's get started. Let's see, yeah. I'll probably just edit that off because that's pretty bad. Anyways, for those of you just joining, we're starting with Axum, this, Tonic. And then we just made this proto, make this bigger, yeah, there you go. We just made this file. Right, so I don't know what any of this does, but we're gonna find out. And my envim is not working correctly, so that's where we're at today. Okay. Even if you're not familiar with protobuf, hopefully the above example is fairly self-explanatory. We need a build.rs file to use Tonic build to compile this file. Need a build.rs. Okay. Go back. Ooh, wait. Build.rs. Okay. So what is this doing? So here, I've not seen this done before. So we need to put a file here. Tonic build figure. Didn't show what you're supposed to put in the TOML, but maybe we can figure that out. Okay, and then we just show the file that we had. And it's compile this to proto, is that what it's saying? Dot unwrap. Main function not found in create build script builds. Something is really wrong with my envim. I'm gonna have to figure that out. What the heck? Okay. Let's try this. There we go. And let's see. So we did this to use Tonic build to compile this file. I guess it needs, this is like how we use the proto-script we just wrote. So finally we have our mammoth of humor. Source lib rs, providing all the items we need for implementing our client server. Okay, so let's go there. Yeah, this is the whole file. So Tonic include proto echo under source lib. I think we can just go into source now. We need to. I can probably do it this way, right? Let me see. And then we can just add. No, that's not how touch works, I think. Why am I not just doing it this way? Okay. Tonic include proto echo. Nice. Oh no. Yeah, my that's weird. My spacebar is my key for other commands in nvim, and it's not working properly. So that's going to make things annoying. Well, I'll fix that later. Let's see. Let's see. So, there's nothing terribly interesting about the client. It's a typical flat-based CLI tool that uses Tokyo and Tonic. You can read the source on GitHub. Let's move on to the important part. So let me just make sure this is okay. Okay, I don't know what any of this is. He's saying just ignore it. Or you can't just ignore it. We gotta put it in there. So let's put it in there. Can I do this? Oh, wait, I have to do this first, right? Crap. Let's do it here. I gotta get better at this. And that's this. Source. Okay. And now we need a then okay. There we go. Now nice. Wait. This is in the wrong spot. Whoops. Right. Nice. Okay. So what is this? What is this going to be? Okay. So we're going to have a Tokyo runtime, async function main returns a result. It's opt parse. Okay. And then this opt parse is going to be something else. So it's going to be derive clap. Structs opt. Okay, so this is the server. I don't know what clap is. Let's see. Long default value is HTTP localhost 1000. Nice. Can I? Let me see. Fiddle with these settings a second. Okay. Here. Nice. Perfect. So what does this do? We're here. So this gets us a server, I guess, somehow. I guess that's coming from the proto stuff. But first we need our initializations. So we're going to use anyhow for errors, I guess. We're going to use clap. We're going to use Tonic transports endpoint. Hopefully these things make more sense later. Echo client. Echo. Ooh, this is like curl expansion, right? That's pretty sweet. So it's going to use Tonic example for both of the things in this list as like a trunk point. Right. And echo. So are those things from, I'm gonna have to build those, I think. Man, the invent being messed up is really annoying. I got so spoiled by it working all the time. Okay, well, I guess we'll figure that out later. We'll figure out where these come from. But now we have our opt server. So let's see. So our endpoint is going to be our opt variable parsed context invalid. Okay. So we let the mutable gRPC is the echo client next endpoint. And then we have to await this because echo client must be a future. Or well, connect must return a future. Makes sense. context. Unable to establish connection. Res equal gRPC echo requests hot message. Why is the spacing weird there? So echo is also going to return a future, I guess. Oh, that's annoying. Okay. Context. Unable to send echo request. See, he said there's nothing special about this, but there is to me because I have no idea what most of this is doing. Print line, debug, res, and then return, okay, its result. So apparently this is supposed to work, but we're definitely missing something in the tom hole. So let's go figure that out. Okay. Are we in the right place even? I don't think so. Let's make sure we do right. Let's make sure everything's written before we close it. Okay. Okay. I guess we need to be here, right? Yeah. Just open this. And then over here. Okay. So we're going to need anyhow. To need Axum. Oh, that's annoying. Anyhow, 0.2. Lab. Tilde. I don't know what the tilde there does. Beta 0.4. Hyper version 0.14 with full features. Okay, cool. And then pin project. Sure, we don't need all of these right now, but we will. Roast. I don't know what that is. Okay, and then. Oh, interesting. Okay, no. So we need Tokyo version 1. Here it is. Cool. And then, okay, Tonic. This is the good part, I guess. Tonic version 0.5. TLS. Not sure what that is. TLS roots. Not sure what that is. And then prost also. So we're doing prost in tonic and then prost itself. Okay. And then we also need tower. Version 0.4. Features full. Okay, and then we're going to have build dependencies. So I think these only run when you like cargo build. Which is what we were doing before, I guess. So cargo build. Version 0.5. Prost. Okay. Okay, I think that's all right. So back to what we were doing. We're going to go straight to the server. Let's see. So first, this should work now, right? Nice. Okay. Yeah, so we imported all this stuff. Tonic example must be I have to figure out where these are coming from. Echo client. Tonic example. There's nothing called echo client. Unless it's no. Yeah, I don't know. It must be a function somewhere. So I'll have to see how it's seeing that. Oh, see, now it's saying something about the heck. Oh. Weird. Anyways, what we need now is to go here. And we need server, right? So okay. So what are we doing with this? The tonic code we put in our library crate generates an echo trait. We put in our library crate. We need to implement that trait on some type to make our gRPC service. Hey. Yeah. I switched to the better inventory a while ago. It's great. I think you're the one that recommended, Lord. I scheduled the next stream for next weekend to do the Lua stuff, but I was trying to mess around with it and I like messed up my config somehow. So now I can't like spacebar stuff. I have to do the old school colons. Just a little annoying, but I did get the auto close stuff, so that's nice. So what is this doing? This isn't directly related to our topic. It's fairly straightforward. I've so far found the experience of writing client-server apps with Tonic to be a real pleasure, specifically because how easy these kinds of implementations are. Okay. Wait, you're not the one I recently recommended in Vimtree to. No. You yelled at me to get the auto bracket closer, which is very nice. It's so much faster. But yeah, you told me to use Vimtree a long time ago, and it's pretty great. It's a lot worse when you can't like spacebar H over to it and you have to like physically click on it, but we'll figure it out. So here we need to use the Tonic example stuff. I also got autocomplete going. That's what I was trying to do when I was looking at some Lua stuff to try to get my bearings. And I definitely did it wrong. Okay, so we need echo server. Echo reply and echo request. Do C control WH. Oh yeah. Oh, well, not like that. Okay. Okay, that works. Nice. Pretty sure there's a command to focus the tree, so you can just make a keybind for that. Have you Luafied your config? Not yet. That's I added a little bit of Lua, but it was mostly just copy and pasting and trying to get something to work. But next week we're gonna stream going as micro optimized as we can. It's just normal switching. Yeah, exactly. We're gonna make an echo struct. Async trait. This is interesting. Async trait. My echo. So what does this do? So we're gonna make an async function. I guess normally you can't do this. So we need the decorator. Go self. So it takes the my echo structs, requests, Tonic, requests, echo requests. Just say decorator? Is that not what it's called? What do you call it? It's like an annotation? Is decorator like only a Python thing? I thought that's what it was called. Decorator is how they're called in Python. They're just attributes. Oof. I like how you bleeped out Python like it's a swear word. Yeah, my bad. I did not mean to offend. Or in this case, attribute macros to be more specific. Okay. Interesting. Well, look at it this way. I'm a little bit more converted over to Rust now, away from Python. So yeah, because the attributes in Rust, I think, are just like shortcuts for adding code to stuff, right? Whereas in Python, the decorators are trying to do some weird magic because Python sucks. Okay. Tonic response new. Go reply. But this needs, okay, so echo reply is also a function. Or new, okay. I see. Going back. Or step get ref. Message. No, wait. I'm missing something. This. It's complicated. An attribute, first of all, is just some information associated with the thing it's on. But in the case of async trait, that's an attribute macro registered by the async trait crate. And a macro is simply a function that runs at compile time, taking in code and outputting other code. Yeah, that's sort of what I meant. But I guess, no, yeah, I guess you're right. So this attribute macro takes in the impl trait and then transports that to something else. Okay. Gotcha. What is it in Python? That's the real, that's what matters, is what's going on in Python. So I'm definitely missing something. I'm missing a parentheses. Where is it? Error expression. This is fine. Okay, I missed both. There's one around format. Yes. One around echo. Oh, the one around OK. Yeah. Ah, this is what it is. I closed this. That's wrong. Okay. Nice. Yeah, in Python, that's a decorator. Works the same, except it doesn't run at compile time because there's no compile time. Yeah. Okay, well, that makes sense. Yeah, I can see how that would be worse if you're trying to do it in a garbage collector way. Okay, so let's see how close we got. So async trait echo. So echo is going to have an async function that returns a tonic response with an echo reply and a status. Tonic response new. Okay. Python has a broken garbage collector because it doesn't immediately delete itself and the code is running. Is that a bug or a feature though? You know? Does it, isn't that what lets you do the like REPL stuff? Or I guess not. I guess it's just broken. You're probably right. So there are two different implementations of main. One of them commented out. That's a much straightforward approach. Let's start with that. So let's just look at this. Tokyo main, anyhow result, address, random port, 3000.into. Tonic transport server builder. Add service, echo server, new my echo. Interesting. Serve address. Oh wait, okay. This uses Tonic server builder to create a new server value. It then calls add service, which looks like implement server type L, add service S, need service returns a router where service request body response box body. It's a named service clone send static. What does all this mean? Did I not get what? Was there a joke that I missed? Oh, I see what you're saying. I thought you meant like the garbage collected memory. Yeah, yeah. You're saying that Python should only be written in disappearing ink. I gotcha. I need more coffee. Nice. Got another router. This works like an Axum, but for routing gRPC calls to appropriate name service. So L represents the layer. Let's see if I can fit all this. Okay. L represents the layer, or the middleware is added to the server. It will default to identity to represent the no middleware case. Okay. S is the new service we're trying to add, which in our case is an echo server. Right. Our service needs to accept the ever familiar request body type and respond with response box body. We'll discuss box body on its own. It also needs to be a named service for routing. It's a bunch of clone send static requirements on error representation. As complicated as all of that appears, the nice thing is that we don't really need to deal with those details in a simple Tonic application. We're trying to go off the beaten path and get a better understanding of how this interacts with hyper. Okay. So into service. In addition to the serve method, Tonic's router type also provides an into service method. Not going to go into all of its glory since it doesn't add much to the discussion. It adds a lot to the reading. Instead, suffice it to say that into service returns a router service. S must implement service request body and response body. Response body is a type that Hyper can use for response bodies. Okay, cool. We can write our slightly more long-winded main function. First, we create our router service value. Okay. So, Tokyo main. Async. Let address equals socket address from why is it doubled up? That's weird. For those, 3 of those. Okay. Now, gRPC service. It's Tonic transport. Yeah, I was right. Server builder. Add service. Echo server. My echo. Okay, and this is what he was talking about with into service. So that's like a service builder, like a factory. Oh, no, that's the service. And then we're going to do the service factory, because you need both for Hyper, I guess. See what he says. Yeah. But now we have a bit of a problem. Hyper expects a make service or an app factory. Instead, we just have a request handling service. So we need to go back to Hyper and use make service function. Okay. gRPC service make gRPC service. Wait. Why don't we just call it make service function? We need to move. What is this? Anonymous connection? Not sure what that is. Let gRPC service gRPC service.clone. Async okay anonymous. It doesn't autocomplete on the side carets or whatever, but I guess that's probably better. How could it know that we do that a lot, I guess? Service. Does it, what? Oh, nice. Okay, so that's going to take our connection and then make one of these gRPC services that we built. Async okay infallible. Notice that we need to clone a new copy of the gRPC service. And we need to play all the games that's splitting up the closure in the async block. Plus infallible that we saw before. But now with that in place, we can launch our gRPC service. So, I'm going to try to launch our service now, I guess. This should be the rest of it. Server is hyper. Server bind. Start server. gRPC service. So if let, and we're just going to do some error stuff. Server wait. Server error. Okay. So we're making the server, connecting it, and then serving our server factory. If you want to play with this, you can clone the Tonic example repo. Run cargo run bin server in one terminal. Trying to open the local host in your browser isn't going to work. Server will only handle gRPC connections, not standard web browser requests, REST APIs, whatever. Got one final step, writing something that can handle both Axum and Tonic services and route them to them appropriately. So he's saying that this should work now. Let's see. I'm gonna do this under my face. It's here. Okay. We do cargo run then server. Build failed. Yeah, that's what I thought. Anyways, let's just keep going. Just keep on moving. Yeah. Box body. What is box body? Let's look into that box body type in a little more detail. We're using the Tonic body box body struct, which is defined as this type box body, HT body, combinators, box body, bytes, create status. Provides its own box body. This is just a body in a box, just like a casket type deal, which is parameterized over the data and error. Tonic uses the status type for errors, this, and represents the different status codes a gRPC service can return. For those not familiar with bytes, here's a quick excerpt from the docs. Bytes is an efficient container for storing and operating with contiguous slices of memory. It's intended for use primarily in networking code, but you could have applications elsewhere. Bytes values function facilitate zero copying network programming by allowing multiple byte objects to point to the same underlying memory. Oh. This is managed by using a reference count to track when the memory is no longer needed and can be freed. When you see bytes, you semantically think of it as a byte slice or byte vector. The underlying box body from the HTTP body crate represents some kind of implementation of the HTTP body trait. represents a streaming HTTP body and contains associated types for data and error corresponding to the type parameters to box body. Full data for asynchronously reading more data from the body. Helper map data and map error methods for manipulating the data and error associated types. A boxed method for some type erasure, allowing us to get back a box body. A few other helper methods around size hints and HTTP2 trailing data. Just throw, yeah, if something's not working, you just throw RCs and boxes at it. Just put it on the heap. It'll work. But they made like a explicit type for it. Right. Which is interesting. It's one of those things that's just so common. Oh, that was the end of part 3, I guess. Okay, let's just go to part 3 then, or part 4. Yeah. Combining part 4, nice. So let's see if we can tie this all together here, because I still don't quite get it. This is the 4th and final post in the series on combining web gRPC services into single service using these 4 things. Okay, single port 2 protocols. That heading is a lie. What? Both an Axum web application and a gRPC server speak the same protocol, HTTP2. It may be more fair to say they speak different dialects. But importantly, it's trivially easy to look at a request and determine whether it wants to talk to the gRPC server or not. gRPC requests will all include the header type, content type, application gRPC. Okay, so it has a content type attribute. Well, not attribute, but you know what I mean, the header. So our final step today is to write something that can accept both a gRPC service and a normal service and return one unified service. Let's do it. For reference, complete code is here. Oops. Should put this here. Put this. Okay. Let's see. Okay, server hybrid. Gotcha. It looks fairly similar. Oh, no, there's a lot of stuff here. Oh. Okay. Let's see where to start. Let's start off with the main function, demonstrate what we want this thing to look like. Okay, we can do that. We just need to make a something like this. Server hybrid. And then where is it? There we go. Nice. So let's just go ahead and add in all this use stuff. So use standard feature, standard hit, socket address, use standard pin. Oh, we're gonna be pinning stuff. Okay. Task. Holding. Use hyper. There's that. Use hyper. Body. And I love the bracket expansion stuff. I didn't even know that was a thing. It's so nice. Body request response. HTTP body. Pin project. Project. Sync. Great. Which is us, I guess. Echo server. Then echo server again. Tonic example again. Except on this layer we're doing echo apply. Echo. Use service. Okay. And I think this bit is the same as what we've just done. Paste that in. It's just our echo struct with the echo trait. So let's do the main, see what we want this thing to look like. Taking a main. Async function main. Address. And it's so nice not having to worry about closing the brackets, because I would mess that up all the time. Nice. So we're making our address. Okay, and this is where it's different. So now it's an Axum make service, because Tower wants a make service and a service. So we have to make the make service. It's a little bit of a tongue twister. Okay. So we're making a new router from Axum. Ooh, this is nice. This is much better. I like this. So we're making root Axum handler get in. So the Axum handler is taking a closure that asynchronously, okay, that was hard, prints, or just takes a string. Yes. So the base root is going to say hello world. Into make service. Okay. Now we need our gRPC service. I said make server instead of service. Whoops. What's that? Transport server. Tonic transport server builder. Echo server new. My echo. Into service. And then this service. Okay. I don't know how I messed that up. So we got our make service and our gRPC service. Let's see if we're caught up. No, we gotta do the hybrid make service. What is that? Hybrid make service. Axum make service. gRPC service. Okay, so we're gonna have some hybrid thing that takes the make service and the gRPC service. And we have to do the make service because Tower needs a make service, but Tonic does not. Or Axum does. Server equals hyper server find address dot serve hybrid service. If what error dot await. So if we await and we get an error, we're going to do this stuff. So we have hyper server bind address serve the make service. Interesting. So we gotta go build some of this stuff then. That's what we just did. We set up simplistic Axum make service and gRPC service values, and then use the hybrid function to combine them into a single service. Notice the difference in those names and the fact that we call into make service for the former and into service for the latter. Saying this versus this. Believe it or not, that's going to cause a lot of pain very shortly. Oh good. Oh goody. Anyway. You're playing Factorio? No, I haven't heard of that game. What is Factorio? This? This looks like it. What is it? Construction and management simulation. This looks crazy. This looks like a like 8-bit StarCraft kind of thing. It's complex. It looks complex. Once you start, you can't stop. Yeah, I always ask whenever someone recommends me a game, I'm like, if I start, will I be able to stop? And they say no. And I say pass. 790 hours? That's nutty. Sounds fun though. Must be. Yet to be explained hybrid function. Spinning up a hybrid server is a piece of cake, but the devil's in the details. There are simpler ways of going about the code below using trait objects. He avoids type erasure techniques since one, I thought the code was a bit more clear this way. Turns into a nicer tutorial. Oh, good. The one exception is that I am using a trait object for error since hyper itself does so, and it simplifies the code significantly to use the same error representation across services. Nice. So, defining hybrid. Our hybrid function is going to return a hybrid make service value. Let's do it. This is outside of main, because we've already got, that's what our main is going to look like. So let's build up to that. Hi, Brian. Hybrid. Make web gRPC. So we're going to use those two types. Then make web. It's going to be make web gRPC. gRPC. Then we're going to return hybrid make service, just like we planned. A hybrid make service that is composed of a make web gRPC. Nice. Hybrid make service make web gRPC. So we're going to need to make this hybrid make service struct, I guess, because right now hybrid is just going to transform these two inputs into the correct type, is what it looks like. So we need to make that type. Hybrid make service make web gRPC. Make web is a make web type. gRPC type. But we don't have those types either, right? Or do we import them? No, we didn't import them. We didn't use them. Which means we have to make them, right? Where? Alright, well, I guess I just don't know what I'm doing. So I don't see them anywhere. I guess it just automatically does it. Interesting. There's a gap there between what I know and what is happening. So, okay, well, now our type showed up, which is good. Going to be consistent and verbose with the type variable names throughout. Here we have the type variables make web and gRPC. This reflects the difference between what Axum and Tonic provide from an API perspective. Oh, is that just part of our... No. No. Just don't understand. We'll need to provide Axum's make web with connection information in order to get the request handling service. With gRPC, we won't have to do that. Either way, we're ready to implement our service for hybrid make service. Okay, well, let's see. So go here, implement service info for hybrid make service. Right, and that has a make web gRPC. Where, okay, so I guess this is where the types are being created. Or make web service connection info. Makes sense. gRPC has clone, as long as it has clone. But this impl needs linked info web and gRPC. So we're going to need 3 types. Okay, so this is the basic tower structure where you have response error and feature type, a pull ready, and a call. So like all the tower stuff looks like this. I'm sure people that are good at this have like snipped or something. Already. And this is always going to have a self, really, I think. Context. Context. And then returns standard task. Results self. And it has a thing. So that's pull ready. And then there's a call, which returns a future. It's mutable self, some connection info, con info, and then it returns its own future type, which is cool. And it does something. So this is the basic structure for these services, which we're implementing on our hybrid make service. So the response is going to be hybrid make service Just hybrid service, right? Yeah, because we're putting this in the make service. So the make service is going to return a service. Make web response gRPC. The error is going to be make web error. And in the future, we're going to have our own feature. Hybrid make service future web. gRPC. Okay. And then what is inside of poll ready? Self. So it just calls make web. And then it just pulls it. Based on the context. Call is hybrid make service future, which we're gonna have to make, I assume. And then web future connection info gRPC right? Yeah. So we're gonna have to have a web future. So make web, which is a service itself, calls with the same connection info as our service. Okay. I think that's right so far. Let's see. We have the two expected type variables, make web and gRPC, as well as connect info to represent whatever connection information we're given. gRPC won't care about that at all, but the connect info must match up with what make web is receiving. Therefore, we have to bound make web service connect info. The gRPC clone bound will make sense shortly. When we receive an incoming connection, we'll need to do two things. Get a new service from make web. Doing this may happen asynchronously, but may have an error. Side note, if you remember the actual implementation of Axum, you know for a fact that neither of these are true. Getting a service from an Axum into make service will always succeed. It never does any async work. There are no APIs in Axum exposing this fact, so we're stuck behind this service API. Clone the gRPC we already have. So once we have the new web service and the clone gRPC, we'll wrap these into a new struct hybrid service. We're also going to need some help to perform the necessary async actions. So we'll create a new helper future type. This all looks like this, which we just did. Note that we're deferring to self.makeWeb, say it's ready, and pass along its errors. Let's tie this piece off by looking at hybrid make service future. We're deferring to self.makeWeb. Let's tie this piece off by looking at hybrid make service future. Okay, so let's look at that part. I'm going to do a pin project obstruct hybrid make service feature. Don't ask me what pin project does. I only vaguely understand it. gRPC. Okay. Oh, does not like that. Okay. So I think what pin project does is it lets us pin this. It lets us go into our struct and decide what gets pinned and what does not. So we need to pin the future. Now I think you have to use unsafe code to do this. So they just put it in an attribute, not a decorator, attribute. Like almost certainly a macro here as well to write that unsafe code for you, which is nice. gRPC option gRPC. Okay, so we have our make service future with a web future and a gRPC option, because the web part needs a future and the gRPC doesn't care. So we're going to need to implement future. I keep doing that. For our make service future. gRPC where future output equals results web error. Okay. I know we're gonna have some stuff in here. First, so future output equals result web error. First, we need to add web future web error and gRPC to this. So that is the types. So we're using web error, gRPC, and web future. Yeah, okay. So type output, it's going to be a result. Hybrid service web gRPC web. All right. The result of hybrid service and web error. Hybrid service has web and gRPC. Makes sense. Okay, and then we need a pull function for our future. Right. Self, but it's a pinned mutable self type. context. It's a mutable standard task context. So output. Okay. So returns a poll itself. So the poll function returns a poll. So let this self.objects. And then we have a match function for this. So this self.project is part of pin_project. And that's what gives you the pinned version of the hybrid make service feature, which we called pin_project on. Okay. And then we match over it. So this .web feature, which is the one that was pinned. Then we pull the web feature that's in hybrid make service feature. I see. Okay. Okay, so if the poll is pending, poll pending. Cool. If we do poll is ready, error, we return a poll ready error. It's poll, because we're pulling a poll, so it's poll ready okay. The web type. That's like a web request. We return poll ready okay. We return a hybrid service. Right. Hybrid service containing the web and gRPC. Okay. The gRPC is this .gRPC take expects not pull twice. What is this? What is this mess? Okay. And we need to close these because I deleted them. Hybrid makes service future projection. Okay, I think that's correct for that implementation of future. Looks like it. Let's see. Let's see. So we need to pull in pin_project to allow us to use or to project the pinned webs, the web feature inside our poll implementation. If you're not familiar with pin_project, don't worry, we'll describe things later on with hybrid feature. When we pull web feature, we could end up in one of three states. Pending, the make web isn't ready, so we aren't ready either. Ready error E, the make web failed, so we pass along the error. Ready okay web, make web successful. So package up the new web value with the gRPC value. So that's the previous gRPC value, because this is the projected struct of hybrid make service future. There's some funny business, yeah, with that this.grpc.take to get the clone gRPC value out of the option. Futures have an invariant that once they return ready, they cannot be pulled again. Therefore, it's safe to assume that take will only ever be called once, but all of this pain could be avoided if Axum exposed an into service method instead. So hybrid service. The previous types will ultimately produce a hybrid service that looks. Let's look at what that is. So let's look at what that is. Okay. Go here. Okay. Doing that. Okay. Whoops. So he said hybrid service web gRPC. So web gRPC. Ooh, this is gonna be a doozy. Implement web gRPC web body gRPC body gRPC body. What? Service. So implement service with request body for hybrid service web gRPC. Jeez. Okay. Where? So web service request body response web body. Okay, and then gRPC is also a service. So we need to implement both of these, I guess, because we're hybridizing them. It's just the same thing. I could have just yanked that. And change this, but that's okay. gRPC body. Okay, and then we need the error for both of these. Into box then standard error sync plus static. That's annoying that it's gonna. Okay, so lifetimes are gonna be annoying with the single quotes. Maybe we I don't know if we're going to be single quoting more or less than making lifetimes. Should probably change that in our config. Put that on the list for next week. Into box down. Although it is nice because single quotes in Rust mean character and not just like a string. Let's see, that's annoying. Send static. So into box dynamically allocated standard error with send, sync, and static. Okay. And then we're going to put something inside these brackets. Right? Right. Yeah. Okay, so let's catch back up. The hybrid service will take request body as input. The underlying web and gRPC also take request body as input, but they'll produce slightly different output, either response web body or response gRPC body. We're going to need to somehow unify these body representations. As mentioned above, we're going to use trait objects for error handling, so no unification there is necessary. Okay. Yeah, so we need to set up these this stuff like before with the response error future and then pull ready and call. Let's do that. That's the first thing that goes in here inside the service implementation. Type response. The response is going to be response hybrid body web body gRPC body. Okay. Type error equals box dynamic standard error plus send sync and static. Yep. I'm not sure why you need like send, sync, and static and that sort of thing, but I'm sure we'll figure it out. I feel like that's pretty basic though. It's everywhere, at least. So future is going to take hybrid future, or is going to be hybrid future, the web future, and then a gRPC future. Okay, and then we're going to need pull ready. So that's the API, is that it's just always returning pull ready. Okay. This takes immutable self in a context, which is a reference to standard task context. Okay. Oh, where was I? Not this. What is that? Oh, what am I doing? Yes. Okay. And then that is going to return standard task results self error. I guess I don't have the formatter set up either, which is subpar. So I was hoping that would just auto format everything for me, but it did not. So let's see. So we set up these things. Associated response type is going to be response as well, but its body is going to be the hybrid body, web body, gRPC body type. we'll get to that later. Similarly, we have two different futures that may get called. Depending on the kind of request, we'll need to unify over that with a hybrid future type. Next, let's look at poll ready. We need to check for both web and gRPC being ready for a new request, and each check can result in one of three cases: pending, ready error, or ready OK. This function is all about pattern matching and unifying the error representation using .into. So let's see, how do we do this poll ready? We already have the types and the return, which returns a poll, obviously. So we're going to do a match over the self-web.poll ready. So we're going to match over the internal poll ready with this context. And we're going to call, so we're going to poll. If it matches poll ready, okay. Then you do another match. So we're nesting a match here. Yeah, so if it doesn't need a web, basically, I think we call the gRPC poll ready. So if it matches the web, then we check the gRPC. And we'll see what that does. So in this match, we're going to do poll ready. Okay. God. Okay. I'm losing it. All right. Already okay. And poll ready. Let me just return it. Right? I did this wrong. Okay, and then it's already error. We return poll, not pool. Already error e.into. Okay. And then for the last one, it's poll pending. We return poll pending. Now, that was the internal match. So we've got to go back to the outer layered match. So it's poll ready error. Already error e.into. Yes. So we have poll okay, which is a nested match, and then we have poll ready error, and then we need poll pending for the outer, for the web, for the web poll. That should match all our permutations of, well, not permutations, but instances of already. So next we'll need call, which is gonna, as usual, take a reference to immutable self and a request body and return self future. I'm messing up the curl brackets here somehow, but we'll see what this call does in a second. So, okay, here we go. Finally, we can see call, where the real logic we're trying to accomplish lives. This is where we get to look at the request and determine where to route it. All of this work for essentially 5 lines of meaningful code. Wonderful. So in this call, we're going to do if request.headers get content type map x.as bytes some application gRPC. So if the bytes from the content type match application gRPC, we're going to do hybrid future gRPC self gRPC.call request. We're going to return that feature. Else hybrid feature web.call request. I don't think this, wait, this does. Okay, so what does this tie to? I don't think this ties to anything. You can just get rid of that. No. What the heck? I just spaced something wrong. This is why you need the formatter. Can I like, does this do anything? I guess not. I guess not. Okay, where were we? Save this. Okay. Hybrid future. That's it. We're at the end. Are we? The final type we're going to analyze in this series is hybrid future. There's also a hybrid body type, but it's similar enough to hybrid future. It doesn't warrant its own explanation. I guess we're going to do both. The struct's definition is this. Okay, so let's do let's just do both. That's this. This is this. So what am I missing? Where does this tie to? It ties to that. Oh, it's way over here. I see. This is where you need the formatter. Okay. Anyways. We're going to do the hybrid body and the hybrid future. So let's see. Project. So this is just changing the name of it, I guess. Because normally it tacks on the suffix. Hybrid body projects. So this is actually an enum. So hybrid body. Web body. gRPC body. Interesting that we're putting it inside of. So we're going to pin body. gRPC. Pin gRPC body. Okay. See, I've never seen this where you like pin it inside of the other type, but that's interesting. But yeah, so we're basically going to do the same thing, but with a future. Let's just future. I do this. No. Right. Nice. Okay. I think that works. Yes. Okay, so yeah, these are pretty similar. Basically the same thing. But the body and the future are going to be different. So let's look at the future. Let's look into the future. First, we got to understand what this is doing, though. Like before, we're using pin project. This time, let's explore why. The interface for the future trait requires pinned pointers in memory. Specifically, the first argument to pull is self. Pin reference mutable self. Rest itself never gives any guarantees about permanence. And that's absolutely critical to writing an async runtime system. The poll method on hybrid future is therefore going to receive an argument of type pin ref means hybrid future. The problem is that we need to call the poll method of the underlying web body or gRPC body. Assuming we have the web variant, the problem we face is that pattern matching on hybrid feature will give us a reference to web feature, or a reference to mutable web feature. It won't give us a pen reference web feature, which is what we need. Pin project makes a projected data type and provides a method .project on the original that gives us those pinned mutable references instead. Okay, yeah. So it just gives you this method to call the code, which is cool. That's super useful. This allows us to implement the future trait for hybrid feature correctly, like so. Okay, so we're gonna do this, and we're gonna do it for the body, and we're gonna see if it works. Finally. Okay. So implement. So we're gonna have a web feature type. We're gonna have a gRPC feature type. We're gonna have a web body. We're going to have a gRPC body. We're going to have a web error. gRPC error. The future. And we're going to implement all that on hybrid feature. It has to be web feature, gRPC feature. Where web feature, see feature output results. Okay, so feature output, where output is results response of body. And then gRPC feature. Result response. gRPC body. gRPC error. Then we need errors for both of these. Static. gRPC. Box dynamic standard. Error. So this is all just the same stuff. Let's see. Crap. There you go. But that's just the where. So we're also going to need types. Type output results response hybrid body web body box dynamic standard error. Send sync. I keep doing that. Okay. Nice. So that's the output type. And then we're going to need a poll because this is the future. So we gotta have a poll. Self. So we're going to have a pinned if it's immutable self. This needs to be a self type. Right. And a context. Standard task context. And it returns full self output, which we defined above. And then stuff goes in here. So we sort of have to match over these pinned, the web pinned web future, that sort of thing. So let's try that. Self. So because we pinned, we have this self.project. We're not calling this, we're just saying project. So the first branch, we're going to try to compare. So we're going to have a match for the web and a match for the gRPC. This first match is just to tell which is which. Hybrid future. And that's why we named it manually here, which makes sense. So if it's a web projection, we're going to match v.poll. We're going to match the poll of the content, and that's going to return something. And then, right, and then if it's, I'm just going to do it this way so you can see it first of all. Future, just the same thing, but with gRPC. Okay. Okay. We're going to return, I guess it's not A, it's B. It would be borrowed. I don't know. Yeah. So we're matching the project over web A and gRPC B. So if we add the contents to this, it's going to be poll ready. Okay, response. Not that. And that would return poll ready. Okay. Let's map. Hybrid. Oh, wait. We gotta do it like this. Type. Hybrid body. Web. So we're gonna map the hybrid body onto it. It's gonna be like this, right? We have to map the hybrid body, web body. Okay. Sort of makes sense. And then next, it's poll ready. error. Return error. Wait, e dot into and then of course all can be pending, in which case you'd want to return open. Now I think this is going to be all similar. Oh, what just happened? Oh, I did it wrong. What? Oh, right. Except it's all gRPC, right? It's not even that different. It's just this. Yeah, nice. gRPC body. Under B. Interesting that there's like an A and B here. I don't know. Whoops. I don't know if that has to be there. So yeah, now okay, so that's cool. We get a pinned reference to a mutable web future and a gRPC future, which is what we wanted. Man, this guy is so smart. That's why tutorials are great. So we also need something similar for the body, because that was just the future. Let's look at what he says first. We unify together the successful response bodies with the hybrid body enum and use a trait object for error handling. Now we're presenting a single unified type for both types of requests. Huzzah. But we're going to need the body first, so let's put that here. All right. So we're going to need to implement web body, gRPC body, HTTP body, hybrid. Man, I keep missing the B key for hybrid body. gRPC body. What is, okay, that's weird. Web body using an HTTP body. Send and unpin. Interesting. gRPC body is an HTTP body. The data is a web body. Data. Send. I wonder why everything here is having to be unpinned. Body error. Standard error. Error. Let's send plus sync static. And I think this is going to be very similar, right? Same thing, except this is gRPC. And then we do some stuff down here. So we need our types. Type data. It's going to be a web body. Data. Type error. It's going to be a box. Dynamic standard error. Error. Send plus sync static. Okay, so those are the types. So this is not a service like the other ones. This is just a body. So we're going to have a isInStream function, a pull data function, and a pull trailers function. So let's see what that looks like. isInStream, this is self, returns boolean, and match with itself. Interesting. Hybrid body web b. isInStream. Hybrid body gRPC. Also b. I don't understand, they're the same. So it's just, oh, it's saying if it's a web, check if it's the end of the stream. If it's gRPC, check if it's the end of the stream. I don't know why those are separated. Why can't you just, I guess they have different types, depending. Okay, and then we need web data, which has self and equal self x. Context. Returns pull option results data self error. This is also going to be a match. Self.project. Since they were pin projected. Hybrid body Rudge, which again is why we named it explicitly b.pull data. So is this recursive? Man, I'm so bad at this. I got so far to go. Okay. Error. So map error. Map this E into, interesting. And then this is going to be very similar. Yeah, basically the same. So that's the pull data. And then the last function is pull trailers. So self in reference self context. Task context. Returns a pull. Results. Option. Header map. Interesting. So here does some stuff. So it takes a pin, reference to mutable self, some context, standard task context. It returns a poll result, option header map, self error. That sort of makes sense. All trailers. And it's the same thing as above, except we're not pulling the data, we're pulling the trailers. Let's just do this. Nice. Okay. I think that's all of it. So let's see where we're at. Thank you, dear reader, for getting through these posts. Are you interested in making GUIs in Rust? Sure. GUI for what? You mean like for Invim? I mean, like 90% of the world uses GUIs, so yeah, seems pretty important. Found the Realm GUI crate and it's awesome. Oh yeah? Always looking for more ideas. Oh, I figured the crap out of that. What is this? What do we got? Inspired by Elm. Elm is cool. GTK. Don't know what that is. Asynchronous. Written in Rust. It's young, but it's not that young. Oh, Realm, like Elm, but with Rust. I like it. Yeah, maybe I should do a stream on this. Maybe once it's a little more solidified first. Is there like an example other than... I'm hoping for like a GIF of an actual GUI. Ooh, here we go. Something like this. What's this? This isn't going to show me, is it? What's this? Ooh. Okay, so like this would be made. GTK GUI. You'll have seen those before. The link you sent. Where did you send it? Did you send it in Discord? Ah. Yeah, I guess it's filtering it out. Or Nightbot is catching it or something. That must be a setting. Half the programs on Linux have GUIs written in GTK. Okay, that's interesting. Looks promising. Okay. Let me see. Let me pull it up. How do I get to it? What the heck? It's weird because it's like, I don't know. I don't see it. Oh, oops. In general. Ah. Discord. I see. I see. Okay, so this is one you did. Where is it? Where'd it go? Here. It's a GUI client for Philips Hue lamps. Oh, this is cool. So you made this? I don't know what these words mean, but I assume this means lamp. Registering at a bridge, searching for bridges. No, yeah, this is sweet. Sub on YouTube. Oh, Twitter. Those are just the names you give your lights. Nice. What is this Nightbot? Nightbot did. I don't remember telling you to do that. Anyways, this looks promising. I'll look into this more later. But for now, gotta finish this up. We're so close. Thank you, dear readers, for getting through these posts. Hope it was helpful. Definitely felt more comfortable with the Tower Hyper ecosystem after diving into these details. Tower provides a rusty interface called service for async functions from inputs to outputs or requests to responses, which may fail. Don't forget, there are two levels of async behavior in this interface, checking whether the service is ready and then waiting for it to complete processing. HTTP itself necessitates two levels of async functions. A type inner service equals request to IO response for individual requests. A type outer service equals connection info IO inner service for overall connection. Hyper provides a concrete server implementation that can accept things that look like outer service and run them. It uses a lot of traits, some of which are not publicly exposed to generalize. It provides significant flexibility in the request and response body representation. The helper functions, service function, and make service function are a common way to create two levels of service necessary. Axum is a lightweight framework sitting on top of Hyper and exposes a lot of its interface. gRPC is an HTTP2 based protocol which can be hosted via Hyper using Tonic library. Dispatching between Axum service and gRPC is conceptually easy. Just check the content type header to see if something is a gRPC request. But to make that happen, we need a bunch of helper hybrid types to unify different types between Axum and Tonic. A lot of the time, you can get away with trait objects to enable type erasure, but hybridizing either style enums works as well. While they're more verbose, they may also be clearer. There's also a potential performance gain by adding dynamic dispatch. You want to review and remember that a complete project is here. Some subjective takeaways. Overall, liking Axum, I'm ready for using it in a new client project. I do wish it was a little higher level and that the type errors weren't quite as intimidating. I think there may be some room in this space for more aggressive type erasure focused frameworks, exchanging a bit of runtime performance for significantly simpler ergonomics. I'm also looking at rewriting our ZHUT project to leverage Axum. So far, it's gone pretty well, but other responsibilities have taken me off for the suitable future. Painful compilation issues to be aware of. I do miss strongly typed roots, but overall, I'd rather use something like Axum than push further root type in the future. Though I may look into providing some root type Axum bridge. This kind of content was helpful. Look for more in the future. Subscribe to the blog. Let me know on Twitter if you have any requests for additional content like this. Nice. This guy's on Twitter. Yeah. Definitely follow this guy because he knows his stuff, apparently. And he likes Haskell, so he's got to be a good person, right? That's how it works. Anyways, do I dare try to run this? Let's see. What are we? Let's hear. What did we call it? Server hybrid. We got an error. What's happening? Build failed. Well, I'm sure the version from the repo works, but I'll have to figure that out. Otherwise, this is very informative, and I sort of know what these words mean now, where I had no idea before, so that's cool. But yeah, I'll look into this GUI thing, but other than that, we're going to be back next week, and I'm definitely going to need people's help because I've never used Lua before, and we're going to try to. I need more people's opinions on how the NVIM should be configured for Rust, because I usually just deal with stuff until I realize it's a terrible way of doing things. Like I was using Bash, for instance. Anyways, that's it for me today, and I will see you next week. Thanks for hanging out.